Short notes on construction materials. In this video, we will be covering about concrete. As civil engineers, we know that concrete is a composite material. It is nothing but the combination of cement with for both fine aggregate and coarse aggregate along with water. The process of concrete production is nothing but starts with batching. Batching is nothing but weighing the individual materials, and then we do mix it with water, and then we prepare concrete. Once it is done, we transport it to the required location, and we are going to place the concrete in the required structure, maybe the beam or the column or the walls. So for that we are going to place the concrete, and then we have to cure it, and then finishing, and then last is compaction. So these are the different stages of concrete production. And STR is nothing but the strength. So here we are going to deal with three basic strength properties, that is nothing but the compressive strength, flexure strength and split tensile strength. For compressive strength, it's nothing but we test it with the help of the cube, and under compression we are going to get the value or get the strength. That's nothing but compressive strength is equal to load applied by area. So next is flexure strength. For flexure strength, you will be casting a beam or a flexure beam. Over that, you'll be applying the load, and the bottom you'll be having a roller support. And then third test is the split tensile strength. We call it as the STS. It's nothing but 2p by pi dl, and you place a cylinder and you apply load at the top, and you apply load at the top and the bottom. Similarly, what will happen, there will be a crack pattern or a split will be observed in the in between the cylinder, and that we are going to find it as the split tensile strength. Next, the term which we are going to see is the workability. Workability is nothing but the ease with which concrete can be compacted to 100%. The concrete should be, it should be easy to work. You have to easily carry it and place it, or easy to port and place it. That is workability. Factors affecting the strength. So what are the parameters, the factors affecting strength? So we'll see certain parameters. If the size increases, or the moisture content increases, if the air voids increases along the aggregate size increases, then there is going to be a drop in your strength. Whereas if the rate of loading increases, or the cement aggregate ratio increases, or the coarse aggregate to fine aggregate ratio increases, the compaction factor increases, and age of the concrete increases. That's nothing but later age strength that gives you high strength. Factors affecting workability are the water content increases, or the aggregate size increases, and well grading increases, well gradation. If all these things increases, then your workability is going to be affected. And if your aggregate cement ratio increases followed by a roughness also increase, then your workability will drop here. Workability measurements. The basic workability tests are being carried over in the laboratories. The first one is slump cone test. Slump cone, it's nothing but the Abrams cone, which consists of 10 cm top dia and 20 cm bottom dia with a height of 30 cm. The simple procedure is you pour concrete into it, tamp it, and then what happens is, like, once the top level is done, you have to remove this cone and check for the slump value. VB consistometer. So in this we are going to assess the time for very dry mixes. So the time assessment is nothing but the shape conversion from the conical frustum to the cylinder. That particular time will be assessed, and that is known as the VB time. Next is the flow test. Flow test is nothing but very high workability. For the compaction factor, compaction factor is nothing but it is a ratio of weight of partially compacted concrete to the weight of fully compacted concrete. Also, this is a table that need to be remembered for the slump, degree of workability, slump value, compaction factor, VB in time seconds. So for high, medium, low, very low, extremely low, the slump values are 100 to 150, 50 to 100, 25 to 50, 0 to 25 and nil. The compaction factor is 0.95 to 0.96, 0.92 to 0.95, 0.8 to 0.88, 0.7 to 0.8, 0.65 to 0.7. The VB values are 0 to 3 seconds and 3 to 6 seconds, 6 to 12 seconds, 12 to 20 seconds and greater than 20 seconds. There are a few definitions like your slump and the creep. We'll see what is meant by slump. Slump is nothing but the subsidence of specimen after the mold removal, that is called as slump. And next is creep. Creep is nothing but the continuous deformation of your specimen with constant load for a longer time. That's continuous deformation with time. And there are some defects in concrete. The basic defects are your segregation. It's nothing but your particles segregate, your aggregates segregate separately. And next is bleeding. You can observe a water line throughout the over the periphery of your concrete prepared. That's called bleeding. And next is the cracks, crazing and efflorescence. These are also the different defects in concrete. Next point to be noted is volume of air entrained in concrete equal to 1. It's nothing but mass of cement to density of cement plus mass of fine aggregate to density of fine aggregate plus mass of coarse aggregate to density of coarse aggregate plus volume of water plus volume of air equals to 1.